I don't know where you're going. Yeah. Volume.
So then he gets up because he's about to fall. And he goes like, I bet you were kicking your feet so he's such a funny word. How did he?
Alright, cool.
My feet, she goes being
We in tie. Alright. Who that? It'll be D'Angelo. D'Angelo. Let's see D'Angelo. Hey D'Angelo, you know how you doing? Hey, the first three people on my row, boy. Aisha here, D'Angelo here, Donovan here, Jaden here. What? The first four? Yeah. Well, not counting Juliana because she's not around until next week. Jaziri here, Khalifa here, Matthias out, Michaela coming on Monday. I see Noah, Nyla, H here, Shamo wasn't here. We'll see if. Hey, Bonnie, you know you're going. JB Harper, JB. My wife's name is Simone Harper. I wonder if you're a family. Are you in relation to Claude Harper? That's the grandfather. In-laws.
You do, you know?
Alright, 1, 2, 3, 4. 1, 2, 3, that's 7. I have 7. Right, cool. What'd you say?
Sour is basically salt.
Well, you see, there's no people who do go party like us often, right? Sour is basically so. Well, I mean, from her perspective,
Sour's no.
Yeah.
this is true.
I know, which is why I don't understand why you can't go check Kevin.
Alright, folks. I sent some things to print there, so we're going to start momentarily. Alright, so we continue in our circle geometry or circle theorem past paper question business. Alright. I'll try and behave myself. I'll let you all try the question, but I like to kind of walk through them, but I had to give you all a chance to practice. Chantal, good evening, how are you? Those, 4 people. So 4 people, well, more than here. No. It depends on it.
Okay. And let them tell me anything, but I don't think she has exam. Are we coming up here for the charger? Oh, we. Go on outside, I like that shit. And your charger's longer. Thank you.
Oh, yes, thanks. Hey, Sian, how you doing? Got extra copy?
Yeah.
Okay, cool. 1, 2, 3. How many I put the print? It was 5 or 1?
Yeah.
Okay, cool. Right, so everybody get a copy. Okay, right. If anybody else comes, we'll sort that out. Right. Okay, cool. Alright. Okay, folks, I think I already started. I'm going to put that Zian. Yeah. Alright. Logan, not. I didn't see Logan. Jaquan, Javier, Janaya, Jair. Alright, well, hopefully they'll pop on sooner rather than later. We'll see them if we see them. Alright. Sorry. One second. The one who sits down next to Khalifa. Alright. Okay, DJ Links and Valentina. You know how you doing. Thanks for the love. Alright. Here's Jair.
I'm so confused with everybody's names, which is really bad.
Here's Jair. Evening, Jair. How you doing? Good to have you on. Alright, and here's Logan. Evening, Logan. Oh, vibes. Hey, look. Right. Ingrid. Minnie. How you all doing? Evening. Okay. Right. Okay, so there's just those 3 people missing. So I guess we'll figure it out as we go. I'm gonna just finish my tea here, make sure my throat hole clear. Hey, good to see you. Let's so close, boy. We.
I know, it's like you only have to do it in one look.
You know what I'm saying? Like, hey, yeah. Everybody right here. All right, cool.
That one, but they can't remember.
All right, so folks, we just trying to do as many of these questions today as possible. Today and Wednesday. Next week, we start in trigonometry from scratch for those who hear. I know some of you are out for the Christmas jobs, etc., etc. Just to give you a bit of just to remind you. Maybe.
You're trying to take my job.
No, well, maybe.
You're trying to get me out the job.
No, you could be her assistant, so I could do some creative stuff.
I don't think you want 9 hours.
Well, you never know. You gotta try.
Unless you want your students.
Nah, I don't think that'll happen. All right.
Nah, not some Chris's watch.
So check it, right? Next week is the last week of school. We know it's a dead week. If you all are home, if everybody is home, and you all want to do class early in the day, we could start it from it, because on the next week, on the 9th, the week of the 9th and the 16th, class is Monday, Wednesday, Friday, 1 p.m. to 3 p.m. for the maths, right? 8 is yeah,
Wait, so only one day.
10 to 12, and then 1 to 3, right? 10 to 12 is POA, right? Oh, Pablo. Yeah, anyhow, so we'll be starting trigs from scratch next week. We'll be clearing off the majority of trigs and then leaving bearings for January. After bearings, we'll try and hit linear programming real hard, real quick, and then we'll just start to revise for mock by doing as many past papers as possible, and then continue that down the road. It has inequalities and right. The only thing I might stop to do during the Easter break is the investigations, questions, patterns, and sequences. And I keep quote unquote forgetting to teach matrices of transformation. So I need to go back and do that because they've been bringing it. I don't usually teach it because they haven't been bringing it for a while. Only recently they brought it back. But construction is a very important part of geometry. Probably not, to be honest. Yeah, most likely. Right, okay. So let's take a read here. So H, J, K, L, and M are points on the circumference of a circle center O. So we have our circle there. Let me get a slightly different color. Right. So H, J, K, L, and M are points on the circumference of that circle center O. And then they specifically said MK is a diameter. So MK is this line here. Mortal Kombat. Sorry, wrong MK. Right, cool. Now, it is parallel to HJ. MK is parallel to HJ. And we could note that because there are arrows on those two lines which indicate that they are mutually parallel. Now, MJ is equal to JL. MJ is this line here. JL is this line here. And we could also tell that they are equal because of the presence of these little dashes along those lines. Right? And angle JMK is 38. So JMK is this angle here, which is the only marked angle in the entire diagram. Right? Now, what I want to do here is before we jump into it, I want to disappear some lines so we could unsee certain things that are there that might make it a little easier. Right? So if I took out, let's say, this line here, and then this line here, and this, okay. Try something. Right, that's the question. Are we seeing the cyclic quadrilateral? Right, yeah. A parallelogram is a quadrilateral that has two pairs of opposite sides, and the opposite sides are equal to each other. So a square is a parallelogram because they have two pairs of opposite sides that are equal. A rectangle is also a trapezium. And a trapezium is said, right? No, a parallelogram. Sorry, parallelogram, my bad. But long story short, usually is that, yeah, that's a parallelogram there. So a parallelogram. No, parallelogram law in vectors, hold on, parallelogram law in vectors is two triangles on top of each other.
Okay.
Long story short.
Great.
But if you...
Two triangles on top of each other.
Right. Okay, are we seeing the cyclic quadrilateral here? What is the rule with cyclic quadrilaterals? The opposite angles are... Very good, which means they add up to 180. Very good. Okay, cool. So we see in that there. Now let's put back in those lines. Let's block off the cyclic quad. If we block off this line instead, sorry. Are we seeing a second cyclic quadrilateral? Oh. Here we go. All right. Now this isn't part of it here. All right. So we've seen a cyclic quad there. Nice. All right. How it went? Oh. You could make. Very good. Is that days like that? All right. Tony falling asleep. Oh God. Pressure. Yeah. And go. Yeah. All right. Cool. You could sleep if you want. So you don't have the boys tomorrow. So you free and clear? Okay, cool. Okay, cool. Okay. All right. Did you want those boys to come in for Christmas at all? Think about it. So we could let the parents know this week, so they can make decisions. All right. All right. All right. We're doing 3 weeks in December, the first 3 weeks of December. Next week is the first week. We're keeping it as per usual in the evening. Unless everybody is home and wants to come earlier and can, as in parent transport wise, we'll do it 1 to 3. If not, next week is normal. The 2 weeks after that, when school officially done, Monday, Wednesday, Friday, 1 to 3 for maths. Hold on. Next week is per usual. Next week is still school. School's still in session. Right? It's a dead week, exams done. So if everybody home and want to come early, we'll do class 1 to 3, Monday, Wednesday, Friday. Right? If people not home, still doing exams, next week is as per usual. But the 2 weeks after that, until the 20th, yes. Right? Monday, Wednesday, Friday, 1 to 3. Right? Unless people say keep it same time. If people say keep it same time, cool. Right? But I have to send in the chat. I was supposed to send 2 weeks ago. Here we are. Anyhow, sorry. Yeah, we'll see how it goes. No problem. Right. So we have a second cyclic quad here. Right. Now if we... Oh, I'll try not to show that triangle for you long as well here. Block off that. Block off this. Block off this. And block off that. Are we seeing the triangle? And the presence of those two little dashes on those sides mean those sides are equal in length, not so? So what kind of triangle do we have? That's very good. Okay, so with all of that now, let's put back in everything that we have to see. Oh, hold on. One more thing. Hold on. This pink line, MOK, is a diameter. A diameter cuts a circle in half. Half a circle is called a... Half a circle is called a semicircle. Half the diameter is the radius, yes. But half the circle is called a semicircle. And if we build a triangle on that semicircle, the angle in the semicircle is 90 degrees. Yo. Who's that, Paige? And,
She just said 30 plus 30 is 70.
well, you could forgive a little arithmetic error. Anyhow, right, okay. So, yes, okay, so you said Spider-Man, so I'm thinking that you're talking about this one here. Right, okay, I could agree with that. So it means that this angle here and this angle will be equal. And this angle here and this angle here will be equal. Because the angles in the same segment standing on the same arc are equal, right? Now hold on, before we go too far, we still want to see what the question is asking us to do, right? So it says, explain giving a reason why HJM is 38 degrees. So let's see where HJM is. Sorry. Right, so HJM. Explain why this angle here is 38 degrees and MJK is 90. But we just explained that one, right? So we know that one. Sorry. I drank tea to clear all that stuff. Helen Homemaker, no. Hello, Helen. How are you doing? All right, so let's we could pencil in why MJK is 90. Why is that again? Because the angle in a semicircle is 90 degrees. So let's put that in one time, right? The angle in a semicircle. Right, okay. But what about this angle here? Why is this 38 degrees? I'll give you a little help out here. Remember that this line and this line are parallel? Is there a line joining them? Aha. So when you have two parallel lines, that gives us scope to use what rules? F angles and Z angles. Right. So we've seen the two parallel lines. Hold on. Let me put this on a different color. Sorry. All right. So the two yellow lines are parallel, and the blue line is what we call the transverse or transversal. And can you see a kind of sideways Z? Right, and the basic rule is the angles in the corners of the Z are equal to each other. That's alternating or Z angles. Right, so that's the rule there. There is this, hold on, sorry. There is this line that is touching those two, but it would have needed to extend it a bit more. So this angle would have been equal to this angle here. But that extension, that is not present, right? So HJM is that this is alternating or Z angles. Okay. Hey, R and RE. How you all doing? All right, so my in class people, are we okay with that one? All right, cool. Jerry, we okay with that? All right. Okay, Aisha, D'Angelo, Donovan, Jaden, Jair, and Logan. If you guys are good with what we have so far, just give me a quick Genie chat, please answer. Right? If you need me to re-explain, give me an R. And let me know which one. You can type like R-A, right? And R-B. All right, yeah, Jair, which one? A or B? Or both of them? A? All right, cool. No problem. Right. Okay, so the presence of this arrow and this arrow along those two lines, Jair, indicates that those two lines are parallel, mutually parallel, right? And as we should know, with parallel lines, we have, if they have a line cutting them, we have scope for what we call F and Z angles, right? If you follow the Z there, right? So these two lines, like I said, are mutually parallel, and they have this this transversal, this other line, kind of cutting them or connecting them. And you can see the Z, right? It's a kind of sideways Z, but it means that this angle here and this angle here are equal. And the rule for that is that they are alternating or Z angles. Does that help at all? You can give me a thumbs up or a thumbs down or yes? All right. Well, you can type yes. All that good. All right. All that could work. Okay. What happened to? Oh yeah. Well, no. Yeah. They were G's first, and he gave me an R. So when I explained to him, he could let me know specifically. Right. You can use G again. All that good. Okay. Right. So that's the first part of the question, and it says determine the value of each of the following angles. Show detailed working where appropriate. So we have a few here. Okay. So what I'm gonna do, I'm gonna draw them in the diagram in different colors. So that way we don't have to scroll up and down or zoom out too much, right? But I need your help to let me know which angles here. The first one is MLJ. Is that the first one? All right, cool. Let me get a different color here because I used pink already. So MLJ is this angle. So let's just call that A, right? What's the next one? MJK? LJ. Oh, right. So I'll put that one in blue. All right, we'll call that one, oops, sorry, 1 second. We'll call that one B. Right, that's the blue angle across here. And the last one is is it MHJ or JHM? All right, cool. That's this angle here. We'll call that one C. Okay, cool. So I'll give you all a few minutes. Sorry, which year is this? This is 2022 May. Cool. No problem. All right, so I'll give you a couple of minutes. So let's just put back in the other angles that we do know, because we did find a couple of angles, eh? So that's 38 degrees, and again we know that this angle here is 90. All right, so that might help us find a few. Well, it might help us find some of the other angles. I can already see how we could find angle A, because we talked about that before, right? We said angle A. What other angle here would match up to angle A? Give me the big letter that it by. What is pi? P-I-E? Hold on, who? Is it a serious question? Like the actual thing of pi, or something in this question that you're seeing here? Yeah, my stepson was trying to show off some digits, but he was also trying to skirt some work he was supposed to do. Anyway. Right, so this angle across here is also equal to A because angles in the same segment. You need help with pi. Like, okay. So what level are you at, Boo? Are you in primary school, secondary school, tertiary education? Form 1. Okay, cool. So when you say you have a math test with pi, are you like talking about circles, like finding circumference and area and that kind of stuff? Yes. Okay, cool. Well, you have two formulae you had to know, right? So the circumference of a circle is like the perimeter, right? And that's equal to pi multiplied by what we call the diameter, the straight line distance across the center, right? Another formula is 2 multiplied by pi multiplied by r, which is radius, right? Now, pi is what we call a universal constant, right? Usually, what they tell you that pi is equal to is either one of two things, either 3.14, or they tell you pi is equal to 22/7. And usually, they tell you which one to use in the question, right? Now, both of those are approximations for pi because pi has a never-ending, and it basically has an infinite number of decimal places, right? So, if you go on YouTube and you look up area and or circumference of a circle, you could even check out Kerwin Springer stuff. He might have some stuff on that. I unfortunately have not been able to make a lot of math material. But yeah, but I had to correct some questions now, right? So I'll check it back if it's still there. If you have any questions, you can put them back. M. Oh, you mean this angle here? An angle there? Yeah, that's true. Oh, yeah, boo, no problem. You're welcome. So yes, this was also angle B across here. Oh, that's somebody trying. The whole, when you say the whole thing. One second. Javier, evening. Just give me 1 second. I'll check this out. Right, hold on. So we have, this is where I'm trying here. This is this one here. So which are you going to talk about? Okay? The whole thing will be A. Because I thought it is. You are correct. That is correct. Yeah. No. Right, so that's a very good observation by Khalifa. So props to Khalifa. So this whole angle, sorry. So the whole angle here is A as well. Because remember, you have an isosceles triangle, right? Right. So if you're going to outline the isosceles in yellow, right? So yeah, so the two base angles are equal. Good. That's a very good spot there, Khalifa. How does that for C? For A? Oh, okay. But you were able to identify that which ones are equal, right? Okay, cool. Well, if we get angle A, we could unlock angle B because B plus 38 would be the whole of A. So if we have, let's say A was 48 degrees. So 48 minus 3 will give us 10. So that angle there would be equal to the B across there, right? The Spider-Man. Right, okay, cool. And then C, if you kind of ignore the triangle in the middle, these two angles are not equal. Yeah, supplementary. Very good. Really? What? Oh, right. Okay, cool. So let me get some stuff going here. All right, folks. So here we go now. I'm going to block out. I'm going to block out some lines here. No, sorry, not that one. Not that. Oh, we're blank, what boy? Hold on. Oh, what going on there? Folks, give me a sec. What happening there? Just now, 1 second. Hold on. You gotta hold on. All right, 1 sec, folks. Everybody. Oh, okay. All right. Okay. It blanked out on my side, and it did kind of zoom out and zoom. Okay. Right. We back up. Right. Okay. Cool. So what we see in here that we kind of blank. Oh, give me a sec. Jake one. Right. I should have copy and paste the papers out of blank one. Oh yeah, because I was supposed to do that. Anyhow, right. Yeah. So check it. Right. We have a 90-degree angle up here. And we have a 38-degree angle here. What is some of the angles in a triangle? The interior angles. 180, right? So if we have 90 here and 38 here, we could find this piece here. Not so? By doing what? In a triangle, what is the sum of the interior angles? Right, so in this triangle that's visible on the screen here, right, we have a 90-degree angle on top of here because it's the angle in a semicircle. They gave us 38. So we could find this angle here by 38 plus 90 and then subtract that from 180. And then that angle there is equal to A because, okay, I did it again. Guys, give me 1 sec. Just now, hold on. I think I might have to go back to this connector. 52. Yeah, 52 is correct. Just now. Give me and a cyclic chord, the opposite angles add up to 1. Yes, they are supplementary. That's correct. I guess I had to call you a full stop. 52 is correct, yeah? So any important tips for partnerships or POA? Yeah, well, I have a whole partnerships playlist on YouTube if you need any tips. And I have all the possible questions work from up to 2003. I'm going to put out 2004 in a couple of weeks. Yeah, you saw it. Oh, yeah, well, that's what I have. There's one thing I had to clarify though, and it has to do with the payment of interest on a loan to a partner. Recently, it came early this year. And I was taught that as an expense. It's a loan interest. But we have been seeing people saying, no, it is an appropriation of profits and should go in the appropriation account. So we are currently trying to find that out. All right. Sorry, again, the shut from that. Right. So 52. Okay. So let me just recap that, right? So in the triangle that is visible on the screen, right, we have a 90-degree angle here and a 38-degree angle here. The unknown angle in that triangle can be found by adding the two values we have, 90 and 38, which is 128, and subtracting from 180, which will give us, 52, because 128 from 180 is 52. Okay, so let's write that. Okay, so angle MLJ is equal to this angle here, which is MKJ, all right? That's MKJ. as equal to MKJ, because angles in the same segment standing on the same arc are equal. Actually, yeah. And that's equal to 180 degrees minus 90 plus 38. 90 and 38 is 128 degrees. 128 from 180 will give us 52 degrees. All right. Elaborate. Hey, Cody. Well, if you missed the series I did on circle geometry, you wouldn't know some of the rules. All right. So I'll try my best to kind of catch up on the rules, but let me check. Let me do one more time, right? All right. Let's check it. What we're saying here is that we wanted to find this angle here. In the triangle on the screen, we know two of the angles. We know that this angle on top here is 90, and this angle here is 38. And if we took 90 and 38 and added A, we get 180, because the sum of the interior angles of a triangle is 180 degrees. But we have 90 and we have 38. We don't have the value here. So if we add up 90 and 38 and subtract from 180, we get 52 degrees. That gives us the value of this angle here. But because of the law in circle geometry, and let me highlight that particular shape, right? Right, so these two triangles here, the way they are drawn, right, it means that these two angles in the bottom corners are equal, and then these two angles in the top corners are equal, right? And that's called the angles in the same segment standing on the same arc are equal. So actually, I'm gonna put that as well. I'm gonna put a little 1 here, right? So 1, all right, angles in the same segment standing on the same arc are equal. All right, I'll kind of shorthand, right? So I hope that helps Cody. Okay, cool. Now we have LJK to find. So LJK is this angle B here. Right? Now, again, because of the same, like we call it Spider-Man shape, hey, behave yourself. So because of this same shape here, right, we know that this angle here is equal to that angle there. Right? So this is the angle we're looking for. We know it's equal to that angle. So how do we find that? Does the 38 have any part to do with it? And yes, because again, if we look at this triangle here, we see an isosceles triangle because of the presence of these two strokes. It means that the lengths of those two lines are equal. So we have an isosceles triangle, which means that these two angles here are equal, which means that this whole angle here is the same as angle A, which we just found as 52 degrees. So to find B, we'd subtract the 38 from the 52. Right? So LJK is equal to LMK. Let's start off by saying that. LMK, let me know, right? No, sorry, this should be in blue, my bad. Well, as LMK, right? Yeah. So LJK is equal to LMK. I'll put a 2 there, right? And that's equal to the same 52 degrees that we have above there, minus the 38 degrees, which is equal to 14 degrees, right? So the rule 2 is that, oh, it's the same as rule 1 above. Okay. And JHM, let's do JHM, right, in orange. So JHM, which is C. Okay, cool. Well, that one easy, and I'll tell you why. All right. Again, let's block out some extra lines here. Right. So if we notice, right, we have a cyclic quadrilateral, and C and A are opposite angles in a cyclic quadrilateral, which means that they are supplementary. They add up to 180 degrees. So all we have to do is take the value of angle A away from 180 and we get the value of angle C. So JHM, right, is equal to hold on, right, yo,
You wanna hear accounts what just happened to the program skills, accounts? Apparently their teacher just messaged them sending a bunch of information that she never taught for the exam tomorrow.
can you send it to me?
Huh?
Can you send it to me?
I will get it. I'm getting the topics now from my friend because she's like stressing.
Yeah.
So I'll get it and then I'm gonna send her the videos.
Yeah, but here what I want you to do for me, right? What I actually want to do is I want to do an Instagram post and tag whoever in it. So if she could add more on Instagram, then I'll tag her and then she could just tag whoever else. Or post it on her stories and we could just get it out there, right? Right, so I'll put a 2 here, right? And the second rule here is that opposite angles in a cyclic quadrilateral are supplementary. Right? In other words, they add up to 180 degrees. Okay, cool. All right, Google Meet. So Aisha, D'Angelo, Donovan, Jadon, Jair, Jabe, and Logan. If you guys are good with what I have, just can you give me a G in the chat? If you need me to re-explain any of them, that's not a problem. Just give me an R for re-explain and then tell me the letter, right? Oh, come to my camera all of a sudden. Sorry, I didn't notice the camera was off. Okay, my bad. Okay, sorry, I got distracted with the camera thing. Any R's? All right, so 1, 2, 3, 4, 5, 6, 7. Okay, everybody's saying good. Okay, cool. My in-class people, are you okay with the answers to this first one here? All right, cool. All right, so let's go. So I'm gonna print this out for you all. 1, 2, 3, 4, 5, 6 copies. All right, cool. Crap. All right, cool. So we'll put that there. To print. All right. All right, diagram below shows a circle with the points P, Q, R, and S lying on its circumference and its center marked O. RP is the diameter of the circle, AB is a tangent to the circle at P. Okay. And we have a 3x, 2x, and an x, and one value of 54. You have it?
Yeah.
All right, thanks. All right, so let me give you a minute so y'all could collect your printouts. Hey, Shani, good evening. How you doing? Okay, she gone? No? Okay. Right. Sorry? Yo.
People would definitely know his grad suit. It's bright gold.
Well, here what to do?
You can't wear it.
No, you could. You just have to know how to dress it up or dress it down with accessories. Right? Now, you don't have to pair it with the same pants. Right? You could wear different pants. Same thing. You could wear a different tie. Or you could do a scarf. You could do an open thing with a scarf. Right? Up to you if you like scarves. Well, let me show this first. Right? We deal with that first. Right. Now, let's take a read, ladies and gents. So the diagram below shows a circle with the points P, Q, R, and S lying on its circumference. So we have P, Q, R, and S. First question is, any particular circle geometry rule jumping out at anybody here? Right, yes. So I see in this one here. You all seeing that too? Right, which means that which two angles right off the bat are equal? Y and Z, correct. Now, it also tells us that RP is a diameter. RP is this line here. And what is the rule with a diameter? A diameter cuts a circle in half. Half a circle is and the angle of the semicircle is. So if we close up shop here, This whole angle here is 90 degrees. And we're seeing a 54 degrees portion here, which means if we wanted to, we could find the remainder, not so? Not so? Right, so, okay, cool, yeah. So this whole angle is 90. No? Right. That yellow line is a diameter. A diameter cuts a circle in half. Half a circle is called a semicircle. If we build a triangle on that diameter, such that all three vertices touch its circumference, the angle here opposite the diameter is 90 degrees. That's the first circle geometry rule we learn. Right? It's called the angle in a semicircle. Right? So if the whole angle is 90 degrees and we have a 54-degree portion here, we could potentially find that piece. How? This is 90 here, and this piece is 54. How will we find this piece? By subtracting. 54 subtracted from 90 degrees. Right, so we could find this angle here. And based on the thing we were talking about earlier, we're seeing kind of Spider-Man thing. Right? What angle on the other side would the pink angle be equal to? Z? No. Y and Z are equal. Because those are angles in the same segment standing on the same arc. And now when you watch it, correct, the 2x. Right? Because of the same reason that Y and Z are equal. S1, you mean 54? Or this one? Oh, yeah, that and this is the same. Yeah. Because of the same kind of double triangle thing. Angles in the same segment standing on the same arc. Right. So we could find this angle across here. Sorry. We could find this angle across here. That will unlock 2x. It will unlock everything as a matter of fact. All right. So with that, I'll leave you to it for a few minutes. If you have any questions, please feel free to ask. It's not a problem. Okay, I forgot my water. Yo. Which one? All right, so P across here, right? So that angle by P is kind of split into three, a x, a 2x, and a 3x. You're talking about any of those, or you're talking about this one here? Like here? Like here? Which one? Yeah, that's correct, because this piece is a what? That is a radius, and this is a tangent. And the angle between tangent and radius is 90 degrees. So that's correct. This is 90. So that 90 degrees comprises of 2x and 3x. What's 2x plus 3x? 5x. So 5x is equal to 90. So you could solve for 1x. And if you could solve for 1x, you could solve for 2x, you could solve for 3x. So write it out. 5x equal to 90 degrees. Yeah, x equal to 18. Yeah. So from there you could solve for the value of 2x. I was wondering if anybody saw that. Yes, that's correct. So this angle here is the angle between a tangent and a chord, which is equal to the angle in the alternate segment. Very good spot, Javier. And of course, if 54 is equal to 3x, we could divide by 3 to find the value of x, and that will give us 18. Yep. All right. So they want us to find x, y, and z. Now y and z will be equal, well, z is equal to y, so that's not a not much to do. To find z is also pretty easy, but let's find x. Right, so we have a few different ways we could find x. So one way we could find x that some people have been using, I wonder if this one boy, right, is again, if you focus on the green triangle, right, this line here is a diameter. It cuts the circle in half, which creates a semicircle, and the angle in a semicircle is 90 degrees. So to find, if this piece of it is 54, we could find the unknown piece. And, sorry, I wasn't supposed to erase that piece there, right? Yeah. And if you follow our rule, right, which we could call the double triangle rule, or the Spider-Man, or the bow tie, or the butterfly, right, the angles in the same segment standing on the same arc are equal. So the pink theta and the pink 2x are equal. All right. So let's see that one out. All right. So let's stick with a pink. Right. Right. So we could say in one instance, hold on, maybe I could copy this one so I don't overclutter any one diagram. Right. So in this instance here, we could say that 2x is equal to the theta, because angles in the same segment etc. Right, standing on the same arc are equal. Right, and to find theta, that was equal to 90 degrees minus 54. Yeah, go ahead. 36. Right, now the 90-degree angle, we put a little note 1 there. Right, so that note 1 is angle in a semicircle is 90 degrees. Right? Right. So it means therefore that 2x is equal to 36. And therefore to find the value of x, we could simply divide through by 2 and get x is equal to 18 degrees. Right? So that's one way to find the value of x. The other way to find the value of x is as follows. Well, one of the other ways is like this, right? So this yellow line here is a tangent to the circle. This green line here, sorry, let me use a heavier weight on that point. This green line here is a chord, right? And the rule is that the angle between the tangent and the chord is equal to the angle in the alternate segment, right? If you close up your triangle. We could blank off these lines. Right? So 3x is equal to 54 degrees. That the reason is because angle between tangent and chord are equal to, sorry. Angle between tangent and chord equal to angle in alternate segment. Right? So if 3x equal to 54, to find the value of x, we simply have to take 54 and divide by 3. And 54 divided by 3 is equal to 18. So we found a second way to find the value of x. All right, cool. Sorry. Right, so let's come back here now. So we found x two different ways, right? That was that. That had no parallel. All right, cool. Now we have to find y and z. So first of all, we could say definitively that y and z are equal. Y is equal to z because angles in the same segment standing on the same arc are equal. Angles in the same segment standing on the same arc are equal, right? Just to save some time. But it's a good idea to know your rules, right? So that's angle y and angle z. Right? So I kind of solve for z first, but let's go back and solve for y. Right, now to solve for y is actually pretty easy as well. Right? Now, we have a couple of different ways we could do it. One way is we could focus specifically on the triangle that contains y. Right? So, and that triangle was the same right angle triangle that we used earlier to solve for that theta there. So if we focus specifically on this triangle, and we ignore this triangle here, right? So if we look at that triangle, the orange triangle, what is some of the internal angles of a triangle? Anybody? What is some of the internal angles of a triangle? 180. All right. So if we have a 90-degree angle here and an 18-degree angle here, how do we find the third angle? Correct. 90 plus 18 minus from 180. So we'll do that y is equal to 180 minus 90 plus 18. 90 plus 18 is 108. 108 from 180 is 72. Yeah, it have a different way to do it. That's correct. You don't know, sorry, what? 54 times 2? Or you got 54 times 2? Well, you know, I can't see what you're talking about, right?
We're saying 54 right there by x, right?
Okay.
By 3x.
Right, well, those two are 54. I could agree on that. But that angle is not inside the triangle. This 3x is quite on the outside, so that has no...
He's talking about the other triangle.
Which one?
So here.
Oh,
To
so,
find z.
okay, hold on. So Mishka just explain. Let me see what you're talking about there.
Yeah, so they found z first instead of y.
Okay, all right, yeah. Let's take a look. So, all right, let me erase some stuff, right? Okay, so the triangle that you were focusing on, Jaziri, is what I'm going to put as the purple triangle, right? This one here. All right, okay. So you were therefore saying that this whole angle here is x plus 2x, which is 3x, not so? And 3x, as we know, is equal to 54. So it turns out that this triangle here is isosceles, which with this side being equal to that side. So that's 54 degrees there as well. Okay, all right. I could get on board with that. And 54 plus 54 is equal to 108, and 108 from 180. Okay, so let's put that. Right, so they'll give him money props. Right, so z is equal to 180 minus 54 plus the 3x, which itself is 54 degrees, right? So that'll give us 180 minus 108, which again is 72 degrees. So yeah, so that gives us angle z, and then when we have angle z, we can find angle y. Okay, I am okay with those. All right, so in person, people, are we okay with Y and Z? Any questions? Anybody? Anything? Sure. All right. Google Meet. You know the drill. If you guys good with that, give me a G in the chat. All right. 1, 2, 3, 4, 5, 6, 7. All right. Oh, okay. All right. Cool. All right. So let's zoom out of that a little bit. All right. Now, another way we could have found angle Z is as follows. Let's take out some of this stuff here, right? I'm going to zoom in here. So I'm going to put back that same purple triangle, right? Sorry, one sec. All right, so just now this one was kind of the one with the most work, but if you were interested, right? And I'm gonna put this one on an orange this time, just to kind of, right? So this angle here, Z, would actually also be equal to this angle here, because this line here, PS, is a what? That is a tangent, and this line AB is a PS or SP is a chord, and AB is a tangent, and the angle between tangent and chord is equal to the angle in the alternate segment. So x, 2x, and 3x is 6x. So 6x, right, is equal to 6 multiplied by 18, which is 108 degrees. And this is a straight line. So if we have this angle on the, well, that side of the straight line, to find the angle on the other side, what will you do? Subtract from 180, because the angle on a straight line is equal to 180 degrees. So if this is 72, that's 72. And if Z is 72, Y is 72. All right, so again, you had another way to find it. Okay, cool. Right, so 21 now. Right, so you'll notice, actually, I'll point it out to you after. 1, 2, 3, 4, 5, 6. Okay, cool. All right, so let's let that print. Let it print. Let it print for the people in the class. Did you, right? No? Oh, Lord. All right. All right, so this is the May 2021. There was an error in this question, and I'll show you what it is just now, right? Oh, he not here today? Cheeks. I don't really laughing. You're caught in the giggle loop or what? You all know are you all familiar with the giggle loop? You ever? Imagine in a funeral, right? And it's one of the most inappropriate times you could possibly laugh. And you think of something funny, and you want to laugh at that point in time. And you hold it back. And then you imagine how funny it would have been if you had laughed. And you sort of laugh again. And you hold that back. And then you imagine how funny it would have been if you had laughed then. And it just stacks. It's called the giggle loop.
I was in my grandmother's funeral. I was like 11, and my dad, everybody was wearing black, and my dad pulls up with these bright pink neon socks, but his pants are like, you can see his whole sock.
Yeah.
And my uncle pointed it out to my cousin and I, and we're in the front row because it's our grandfather's funeral, and we started dying laughing, like screaming laughing, because my dad goes up to say like the eulogy. And it's like full pink song. Because everybody stared at me. It was so scary.
Yeah. You know, it's been funny. Like if whoever go up to the eulogy, like if it was you go up to the eulogy, and like you ended up farting, and like grandpa, you know, like he's a corpse. Anyhow. Right. Okay. Cool. So in the diagram below, E, C, G, and F are points on the circumference of a circle. Okay. Cool. So E, C, G, and F. Yes?
Yeah.
Right. EG is a diameter. EG is this line here. Right? So once we see a diameter, what rule must come to mind automatically? Anybody? Once you see a diameter, what rule comes to mind? The angle in a semicircle is 90, which means this angle here is 90, and this angle here is 90. Okay. The tangent AEB is parallel to CD. So AEB is this line here, and it's parallel to CD. Now CD is called a secant line. All right? Because it kind of cuts through the circle, right? Okay, and of course, we know that they're parallel because the presence of these arrowheads indicate that they are mutually parallel. And we just saw in a previous question, when lines are mutually parallel, it opens up scope for what? F and Z angles. Okay? Now, okay. Angle AEC is 68 degrees. That's this one here. And EFD, right. So that's the mistake they made in the question. I'll show you why. So I actually, hold on. Right, so that, oh, okay, no, right. Yeah, so it 106, I want you to put that this is not 106. This is 112. Right? There was a mistake in the question. Okay. I'll show you what after. Now, what I want to do is I'm going to mark on the diagram the angles they want us to find so we could zoom in a little bit more. So the first angle is ECD. Right? ECD is from E to C to D. So that's this angle here, which we will call small a, right? So that's small a. Right? And they want CEG. So CEG. Right? So that's this angle here, which we will call small b. Small b. And then CGF. CGF. So that's this whole angle here, which we'll call small c. All right, so I'm going to zoom in here so we could get a slightly better look at the question, right? Okay. All right, and don't forget, the orange line is a diameter. All right, so I'll give you a few minutes after we kind of did our little preliminary inspection there. You laugh so hard, your jaw crack? What's going on there?
My joke. When he said his jaw was too big, so I went, and I can't my jaw, but I cracked it too hard.
And you're chewing gum still? Well, some people do, yeah. TMJ, yeah. Something.
My jaw, right? This is the circle for my jaw. This is the bone. My jaw, it goes and it slips off the bone. And it slips off the tissue and it's bone.
Yeah, when that happened there. Something mandibular, something.
It doesn't.
You just said it.
Well, it hurt when I did that, but it doesn't hurt normally.
Just like getting abused.
You're getting abused? How are you getting abused? Well, there are other parts. There are other parts with which you can hit him. Hit him. Hit him.
I mean, even trusting you, you see that, right, Chris?
Yeah, I did.
Even trusting you, say, I'm going to say 8 years.
I'm married. I don't know what he's talking about.
Well, you know what I'm talking about there?
Not really.
Okay, cool. Right. So the orange line does what? The orange line is a diameter. It cuts your circle in half, right? Okay, cool.
O is the orange, like the O.
The O is the center of the circle. Right. And from O to E is a radius, and from O to G is a radius as well. Okay. But we also have those two yellow lines. What do we know? They're parallel. And we know with parallel lines, we have scope for F and Z angles, not so? So for example, if we follow this line down here, well, we don't have any F's right now, right? So if we focused on, let's say, the blue Z, right? This angle here would be equal to this angle here, if we were to find it, okay? But we also have a next line cutting or connecting both of those parallel lines. And if we follow this Z, what angles are equal therefore? 68 and A. A is 68 because of alternating angles or Z angles. You'll stretch that out, I don't think you're going to use it because you're here not long enough. Yo! Right, so, right, okay, so hold on, let me draw it in, right? That's for, as for ECD, as, yeah, right, yeah, that's ECD, right, so as Javier was saying, this angle here is 90 degrees because this is a radius and this is a tangent, and the angle between tangent and radius is 90 degrees. So if you have a 68-degree portion on the outside, you could find the green portion by doing what? Subtracting 68 from 90. 68 from 90, sorry, yes. That's correct, Ravi. But were you continuing on from that? Was there something else attached to it? Or was it just that? Right. Right, so hold on. This is 22 here. I agree with that. Right, so you're talking about finding this angle here using 22. All right, so which triangle are you using? Right, so you're talking about this triangle here? Okay, cool. So we would need this angle here. Right, so this is 90 degrees here. I could agree with that. Right, okay. So you have 90 there. You have 22 here. So you could find this, which would be 68 as well. I'm not seeming right. Hold on, but the logic song. If that's 22 down there, and this is 90, this had to be 68. No, and it's true, because if you follow your angles in the same set, sorry, the angle between tangent and chord, so this 60-degree angle here would be equal to this angle here. And this angle here. Right? And if you follow your kind of, yeah, so those two angles are equal. Wow, okay. Right, okay. So then you could find that that's 68 here, that's 22 down there. But then how we splitting it into 60 and 22 there? That's my question. Yeah. 1 second. Alright, hold on. Just now. Let me take off the purple stuff for now. We'll come back to the purple stuff, right? Okay. Get rid of that. Get rid of that. Get rid of this. Okay, are we okay with the initial answer of A being 68 because of alternating angles? Okay, cool. So the next question is to find B. So this piece of the orange line from the center to the circumference is a radius, not so? And then this line down here is a tangent. And the angle between radius and tangent is 90. So this whole angle is 90. So if this whole angle is 90, and you have one portion of it being 68, can we not find the green portion? 90 minus 68, right? Right, so, okay, I guess I'll put it in green because I give that angle that color. So B is equal to 90 degrees minus 68 degrees, which is equal to 22 degrees. Okay. Yo. Uh-huh. You could. Right. So you could. So you're seeing the cyclic quadrilateral, right? Okay. Let me outline the cyclic quad for those who may not see it, right? So if we close up all in blue, that is a cyclic chord. And then the opposite angles are supplementary. Yes? Okay. So then we'd have to find the angle on this side to add to the B. They happen to be in this case, yes. Right. But hold on. Let me show you something else you could do, right? Let me show you something else you could do. Okay. So the angle C could be broken up into two pieces. It could be broken up into. Okay, I'm gonna do orange, right? It could be. Hold on, sorry. No. Wait, I just want a little. Right. Okay. Cool. Right. It can be broken up into an orange part and a purple part. Are we okay with just splitting it into two separate sections? Okay. Here this, right? If we do our kind of Spider-Man or butterfly, whatever you want to call it, right? You're seeing it there? So it means that this angle here and this angle here are equal. Now, if we go back here, this angle is 68, which means that the purple portion is also 68 degrees. Right. Now, the other piece, let me go here. Sorry, I'm going to go here. So we're using the same rule, but look which way we're going. We're going from here, diameter again, back up here, and back up here, right? Which means that this angle here and this angle here are the same. Can we agree? Ha! Now, check this. This line here is a straight line, not so? And the angle on a straight line is 180. And if we have 112 on this side, we can simply subtract it from 180 and get the piece, this piece here, which is equal to that piece there, and then they add it together. Here the interesting part. There's another way we could find this angle here. If you consider that this line here is a chord and this line here is a tangent, what's the rule? The angle between tangent and chord is equal to the angle in the alternate segment. So it means that this angle here and this angle here are equal. And on top of that, because this angle here is also the angle in the alternate segment to that. Yeah? So that would be equal to this piece here, yes, and this piece here. Right? No, you're correct. You're correct. If you follow your Z, that's correct. Right? Yes, because this is 68 and this is 68. So what we then discover is that these two lines are equal. And we also discover that these two lines are equal. So we have a lot of equal lines that we end up discovering. All right? So, yeah. So this angle here is also happen to be 68 degrees. Yeah? Which will give us this angle here and this angle here. And this angle here. So, yeah. So, let me go back. Where it was? Here? Yeah. This one here? All right, hold on, just now. Give me a letter. Is that here? Yeah. Yep. Yeah, because if this angle because of z angles, this angle and this angle here equal because of angles in the same segment standing on the same angle. Yeah. Well, once you know how to look for it. Now, I did hear somebody say, I don't know what's going on. If that's the case, so like I'll be playing. But let me looking on and see what's going on. And if you don't, then I'll ask my question. I know you had dengue, but it's not an excuse. Okay, so wait, hold on. So angle A, right, just now. Angle A was equal to 68 degrees, and the reason was alternating angles, right? The green angle B was equal to 90 minus 68, and that was equal to 22 degrees, right? And this was angle in a semicircle. That's how we got the 90. Angle in a semicircle, sorry. Sorry. Right? And then the angle on top there, C, right? That was the slightly more interesting one to find. Yeah, you had that one had a few more layers, right? But that angle was equal to we could break it up into again the two halves, right? Right? The orange half, which is CGE, right? CGE, so that's equal to C, right? GE plus the purple half, which was FGE. Right? And we said CGE, right, was equal to this angle here too, which was 68 because of 180 minus 112. 68 plus, and then FGE was also 68, and that was equal to angle A. 68, so the total value there is 136. Right. Now for the 68, so for the orange, so let's say that as 1, and then this is 2. Right? So remember they wanted the reasons, right? So the reason for the orange one was twofold, right? It was equal to 68 because angles in the same segment, and we got 68 because of 180 minus 112. Right? So right, angle on a straight line. That's how we got the 180. Right? Angle on a straight line and angles in the same segment. Standing on the same arc are equal. Right? So that was the orange. We had two things. Now again, we had many different ways to find this, right? And the purple, right? So it was that FGE was equal to FCE, FCE being A, right? And then 2, FGE is equal to FCE, which is angle A, and same thing, angles in the same segment. Standing on the same arc are equal. Right, yeah, so that one had a few layers. And again, the reason that 106 was wrong, because if you took 106 from 180, you get 74. And this couldn't be 74 given the rest of the angles. Unless if it was 74, then this angle here should have been 74. Because we didn't know, they had to give both of them correct. But I chose to go with the 68-degree angle because that one just kind of flowed a bit more naturally, in my opinion. I think that was the one they wanted. All right. Okay. Google Meet, if you know the drill, right? If you guys are good with all, give me a genie chat. If you're not good with all, let me know which one, right? If you have an alternative working, you can let me know. right? All right, cool, thank you. All right, so again, 4 out of 7 now. All right. Okay. Well, the next three will let me know when you get a chance. Okay, in class, people, talk to me. Are we okay with this question? Any further questions? Anybody anything? Okay, cool. All right, so 2021 Jan now. Oh, that one is just alternating angles, to be honest, because the two yellow lines are parallel, and they're being joined by that blue line. So it creates the z angle or the alternating angle. Make sense? All right, cool. Yeah, sorry, I'm now seeing your question. Sorry about that. I kind of look away already. All right, I had to reposition some of these things, boy. All right, small thing. All right, so let me put this to print. Push it into a fan, like. Okay, when you say a fan, like somebody who's following you online, like a person, or like a fan as blow breeze.
Not true. Picture.
Were you very warm and you tried to help you out or something?
Exactly that.
Oh, okay.
She was sweating, like tripping. So it's like, so now you're admitting. It was no, listen, because I couldn't find any breeze. And she objected, so you know what? I said, you know what? I will lift you up and put you into the fan.
Because you know what she needs better. Exactly.
Yeah, like, she
Why is he knows his picture now?
no, listen. She resisted and somehow she ended up on top of the fan.
Well, it can be somehow. You say you pick up and you put her, so it's not somehow.
Sorry, correct now.
And we in maths class. The maths not mathsing in maths class. That geometry not circling. The fan was probably circling, but
What's all these people to you?
and the school not far from the police station either. That is the next interesting part. All right, ladies and gents, we on the screen. Let's take a look. Right, so in the diagram ABC and D are points on the circumference of the circle with center O. AOC and BOD are diameters. AOC and BOD are diameters. So once we see diameters, you know we have scope for what rule? The angle in a semicircle is 90 degrees. So where would those 90-degree angles be? So for the green triangle, they would be, green diameter it would be here. And for the pink diameter, where would it be? It would be around here. All right, so we have two 90-degree angles there. And we could also see something else here, right? If you follow that, this angle here and this angle here are equal. So he call himself when he was talking himself?
My bad, Chris. I needed to remind my father that he had to pick him up. He used to forget plenty.
Okay.
Like real plenty.
Well,
Real plenty.
all right.
Like actually plenty, I like real plenty.
Okay.
Like if I tell him something, I'm about to remind him next 5 minutes again. He forget.
Because he forget it's like a lot.
Yeah,
Like
a lot.
like around plenty.
Like real plenty. Right. Okay, so state the reason why angle ABC is 90 degrees. ABC is that pink angle on top there. What's the reason? The angle in a semicircular, is 90 degrees, right. Now, they gave us something else. A, B, and DC are, what's that word? Parallel. And the presence of these arrows along those lines indicate that they are parallel. And parallel lines give us scope for F angles and Z angles. No. We will find them in the earlier part of the paper. You would not usually find an F angle in circle geometry. You quicker find a Z angle. It's not impossible, it's just not usual. Okay, right. And then determine the value of each of the following angles, show detailed working when necessary, and give a reason to support your answer. So they want BAC. So BAC is the 2P angle. Angle Q, they also want, and we already said that those angles are equal because they are angles in the same segment standing on the same arc. And then they want angle R thereafter. Okay, cool. So I'll give you a minute or two, organize that, and let's go from there.
No.
What's that?
Basically, same way when with math.
Okay.
No.
I'm glad to hear you say that.
Yeah, in total, in various questions, T-Tech.
Not here. People are in the term exams and kind of tired, so they.
I had school, then football, and
Yeah, don't worry. My son wake up 2:45 this morning, scream crying till about 3:30, and I had to go back to sleep and get up 5:30 to get my stepson up and ready for school, and drop him, carry my son to the doctor, wait for him to pee there. He happened to pee and poop at the same time, so they couldn't take the test. Carry him home, then go back up the road to carry the pee back for them, then come back down the road, pass it in the grocery and the mall, and then come here. Yeah. When I go home, well, we have a lady who helps us, and the biggest help right now is she cleans the bottles and the wares. So when I go home, I don't have those things to do. The bottles, the baby bottles, and the wares, because we have 2 sets of bottles now. All right. So when I go home, it's maybe to pack my stepson lunch kit for the next day. If my son going to school tomorrow, pack his bag too. That's what and then my wife going to bed. I'll just watch the baby, and then we might watch nothing because we're too tired, and then go and sleep by about 11. And then baby will get up around 1 to feed, then 3, and then the older one I get between 2:30 and 4 to feed. Yeah.
Thanks, Lucas. Changed my whole life.
What kind of fence will this play on? What kind of fence this play on? He says defense force. What kind of fence? You stream with groceries too? Is that what you say? Or Bruce Lee? What do you say? Right. Yeah, that'd be real cool. Like 16 and thing on the AC. Yeah. Well, if you're climbing too much fence, I'll be tired too.
No, you think groceries? You think groceries can actually win against
Big team or
yeah, your biggest team.
not the we biggest team is
Yeah.
against defense was biggest team.
Yeah.
Well, I'd say against the tier 2 team. You need to eat.
Mm-hmm.
Alright.
2P and Q and R are equal, yeah. That's correct because this is a radius and that's a radius. So the triangle built on the radius would be equal. That's correct. I agree with that. And then yes, if you follow the z here to here, this angle and that angle are equal. That's correct. Okay, so let's talk about that. Right. So we know that pink line, that pink line is a diameter, right? Let's close up the triangle. Right, so this angle is 90 because this is a diameter, right? But if you notice, we have a blue angle, 2p, and let's just give that other angle a green color so we could call it green angle, right? And there's a green angle here, right? And actually, that just to emphasize.
That is abuse.
Right. So you see that one triangle there? And what is some of the interior angles of any triangle? 180. So the 90 plus 2p plus 3p is 180. And what's 2p plus 3p? 5p. That's correct. So that's your statement. Go ahead, no? Yeah. Right, so 90 plus 5p is equal to 180. Right, go from there. It must mean that 5p must be 90, because 90 and 90 is 180, not so? And if 5p is 90, how do we find p from there? Which is the same value we had in the previous question, 18. 90.
So sometimes I might not be able to come because I'm training night from 6 to 8.
Okay. Well, that's what the replays are sent to you. So whenever you get a chance, so that'll be the same night. If you're tired, the next day or the weekend, you can check out the replay. There's in the chat, right? Yeah. So all the replays are sent right after class is done.
Yeah, because it's only same days like Monday, Wednesday, and Friday.
Yeah.
Monday and Wednesday.
Well, if the replay is not working, let me know and I'll see if you can shift it around to the next class. Because we have a class on a Tuesday, but that's just Fatima boys, so you might want to go in that class. And then it's about 5 Fatima boys in that class. So we just do what they do in school. The Thursday class, I had a C. One of the girls switched to the Friday. So that might be possible. But that's Thursday for the 6 or 6 to 8 on a Thursday. Though. 6 to 8. 18.
So we're taking up one of the classes like in the morning.
Right, yeah. But that's right, yeah. So for the December period, yeah. So next, hold on. Like I was saying, next week, which is the week of the 2nd to the 6th, right? Classes per usual. The 2 weeks after that, classes Monday, Wednesday, Friday from 1 to 3.
1 to 3.
Yeah.
Okay, that's great to me.
Right.
Great.
And when January come, back to normal.
Like great at talking about it.
Like cheese or like coconut? That's like I was on a Twitch stream this morning with a creator as follow, and he said something about there are two kind of people in this world: something about who know how to do business and who don't know. I said, well, the last time I heard, I had 3 people in this world: those who could count and those who can't count. It depends. No, hold on. It depends. It depends. But let me hold on. We're talking about maths here, not that kind of maths, right? So let me get back to this. Right. So we outlined this triangle here in pink, right? Let me sound like a bug spray now. Anyhow, right. So the sum of the interior angles of a triangle is 180 degrees. So we know that this angle on top of here is 90 because the angle in a semicircle is 90 degrees. So the sum of that angle plus these other two must be equal to 180 degrees, not so? Oops, hold on. Right. So, sorry. Angle in a semicircle. If I had one wish, I wish that I could write perfectly with this pen. Or with anything, right? That way, It will come out real nice. Anyhow, right. BAC. So angle BAC, which is this 2P angle here, right? So we know that if we take 90 and add it to 2P and 3P, we get 180 degrees because the sum of the interior angles of a triangle is 180 degrees. What's 2P plus 3P? That's 5P, right? Now to solve for 5P, therefore, we'll have to minus 90 from both sides of the equation, right? What's 180 minus 90? Good. So it means that 5P is equal to 90 degrees. And to solve for P, therefore, we'll have to remove 5. How is the 5 attached? Multiplication. And how do we remove something attached by multiplication? Correct. We use the opposite operation, which is division. And P will therefore be equal to 18 degrees. Correct. So now to find the actual value, we have to take 2 and multiply it by the 18 degrees, which means the answer is 36 degrees. Cool. So that's BAC. Now angle Q is that angle down there. Right? If, or as the man say, if, right? If we follow our butterfly or bow tie or call, we get that the angles in the same segment standing on the same arc are equal. So 2P and Q would be equal to each other. Right? So Q is equal to 36 degrees. Angles in the same segment. Are equal. And then calculate the value of angle R. Okay, so R is that angle down there. Well, as we could see, it's already in that same kind of angles in the same segment, right? But as Khalifa pointed out too, we don't have to worry about that because look, this triangle across here. Hold on. Right? This is the center of the circle, which means this is the diameter and this is the diameter. And all diameter, sorry, a radius, wow. As a radius, those two are radii, and all radii in a given circle are equal. So if you close up your triangle here, we could say that this angle here and this angle here are indeed equal. And on top of that, the other way we could have done it is following the Z angle. Right? So those two orange lines are parallel. And we have this blue line cutting them, which creates the Z. So 2P and R are equal, right? So you have different ways that you could solve for R. You could also say that, hey, look, remember this angle here is 90 degrees. And we found that P is equal to 18, so 3P would be 54. So 90 minus 54 is 36 degrees. So you have a next way to find it. So you have different ways to find the same angle, right? R is equal to 36 degrees, and you can say Z or alternating angles, right? Or 90 minus 3P. If what? What about 80? It's okay, well tell me, Chris, it's cool. Yeah, okay, well, here what we do. We'll put it on blower.
On off? Yeah, that's not a good idea.
Hold on. Auto, cool. What's the blower? Okay, well, here what? Let me put on 26 now. Yeah? Okay, cool. We could do that too, if all you're that cool.
I mean, yeah, I think we should kind of go off. Thank you. Off.
All right.
Thank you.
Okay. All right, in class, people, are we okay with the solution to these items here? Yeah. Any questions, anybody, anything? All right. So, Google Meet. If you all are good with this question, give me a quick Genie chat. If you need me to react in any of them or all of them, you tell them no. Give me an R and tell me if it's part A, part B, or part 3. There's an actual angle R which you asked us to find, but you can't use R for R. Maybe you could. Alright, that's 4 out of 7. Well, I mean, light off or what? Oh, so it's still wet. Alright, cool. Well, don't worry. Zuni.
Nah, it's probably my brand. You don't understand why.
Right. Okay, cool. So let's go. Jan 2020.
Okay. You not group? What's your name again?
Right. So this is Jan 2020. It might be the last question for the day, but it depends. We might finish fast. You never know. Right. So we're looking at the Jan 2020 question that's on the screen right now. Okay. So the circle. Hold on 1 second.
284?
One there. Hold on. Right. So what went on there? What was off? Okay, back now. Alright, so Google Meet us. I hope you all hear me. Okay, so it says the circle shown below has a center O and points A, B, C, and D lying on the circumference, right? So center O. If the center is O, what does that tell us about the line BOD? It's what kind of line? Diameter. And what rule comes with the diameter? Your angle in a semicircle is 90 degrees, right? Cool. Now we also could see that we have a line here and a line here. Well, and this line too. And they're all started from the center and going. They're all radii, correct? So this triangle here is what kind of triangle? Which, because this side and this side are equal, which means that this angle here is equal to what? 37, right? Which means you can find the whole angle here if necessary. All right. Anyhow, and also, you might be tempted to say, look, why is 37? No, it's not. Because it's not the same shape. It looking like two corners, yeah. Correct. Now the thing is, if we were simply to draw that there, but then you see there's no guarantee that it went. Actually, would it matter? Yeah, it would. It would. Yeah. Yeah. So you can't assume that. Correct. Right. Now, as I was saying, this line is a diameter, right? So that means that we have scope for angle in a semicircle. So if you close up your triangle or you build your triangle on the diameter, it means that we have this angle is 90. And if you have a 49 here, you can find angle Y. Correct? No? Oh, this is 49, yeah. But this is 90. So to find this third angle. Yeah, correct. Right, so quick things. Write down the mathematical names for the straight lines BC and OA. BC is this line here. That is a chord. OA is a radius. Radii is the plural. That's all right. And then I want us to find angle X and angle Y. So we said we know this angle here is 37 degrees. So we could find X because the sum of the angles in a triangle is 180. And then we know that this angle here is 90. So we could find angle Y pretty easily. All right, organize that for me real quick. And let's see, maybe we should try 2019 as well. How many angles there? 3 angles? All right, yeah, man. I'll put out the print one time. Right, sorry.
Rascal.
Well, some people do, eh? Well, sometimes we are the only people who understand ourselves, but it's good to get.
So Chris, Khalifa, has $210 for the form teachers in high school because she just joined the family.
If you throw her into the fun, how she have money for them?
I didn't contribute.
Why you still lying? Why you still lying?
I-
You wasn't the one who now say a picture.
Right. So angle
Shake my
X. Shh. Right. So angle X. Right. Correct. So 180 minus 37 by 2. That's 74. 180 from 180 minus 4 is 106. Cool. And then angle Y, right? So that's 180 minus 90 plus 49. Correct. So you see, sometimes they give us some easier questions. So that's 49 degrees. Right. I'm going to the reasons, right? Angles in a triangle sum to 180. Angle in a semicircle is 90 degrees. Base angles of an isosceles triangle are equal. Okay, all right. So let's see if we can get through one more before time is up, right? So Google Meet, I'm gonna go to the next one, right? If you have any questions, let me know. Right, but you can hold on to the G's for now. All right. I printed it out, right? Right. 2019 May. 2019 May was a very interesting paper, to be honest. Right. They want DBA. DBA is this angle. Hold on. This angle here. So we'll call that angle A. Then they wanted DAC, which is this angle here. So we'll call that angle B. And the last one is BCE, which is this angle on the outside here. Oh, let's call it angle C, sorry. Yeah, that one actually is easiest to find. I lie. A is easy. B is... Oh, B easy too. Oh, this whole thing easy. Sorry. Yeah. I'll give you a little hint if you need it. So we can see what B is equal to right away. This is the diameter, which means this whole angle here is 90 degrees. And this is a chord. Oh, no, sorry. I got angle C wrong. Oh, no, okay. Was this whole thing here? A cyclic quadrilateral. So the rules are that the opposite angles are supplementary, but there was an addendum. The exterior angle is equal to the opposite interior angle. Cool. So that's a hint. Yep.
My ride is here.
All right, cool. Well,
Picture? Penny. No.
well, when,
Send her a picture.
well, Wednesday then. Of this?
Yeah.
If you give me 1 minute, I'm done.
Huh? Okay. She's a thief, huh? Look at her. You don't get? You have 6. Why would she get? I have none. Why would I not get?
Yeah. I was also sending a PDF for you in the chat too, so you could always put us up there.
Oh, I forget I'm not chatting now.
Well, maybe you're taking after your pops then. Since he's
Yeah, you
forgetting.
see, I said, see ya.
BCE is equal to DAB. DAB being the whole angle here. DAB. What's that? Which is equal to 46 plus 28. To 74, right? Right. So the exterior angle of a cyclic chord is equal to the opposite interior angle. Right. So these two actually were relatively easy compared to the stuff we did before. All right. Okay. Google Meet, can I get a G if you guys go with the solutions for this one? Please don't ask. If you need me to re-explain, let me know. No problem. Okay. Work on some cool breeze. Okay, so folks, we will spend one more day on circle geometry participle questions. As you can see, I have quite a bit lined up again. All right, so today we did from, I think, Jan 2022 or May. No, Jan, yeah. So 1, 2, May 2022?
Oh, yeah, John.
No, yeah, couldn't be this one. Yeah. No. I can't remember. Wow. Yeah,
No, John.
it was John. Yeah. No, it was me because it was the parallel lines. Yeah. So May 22, Jan 22, May 21, Jan 21. So about 6 questions. All right, not bad. Right. So we'll see. My wallet upstairs. So I'm organized, right? All right. So Google Meet. I'll go on there. I'll see you guys on Wednesday. Have a good evening. Bye.